Hello, my name is Elvis, and today I'm going to be talking about a page called Afrogeek. Afrogeek is a page that's going to be talking about computing, electronics, and also projects on electronic conception and on computing. So in Afro, we means a bit of Pan-Africanism. We think that Pan-Africanism shouldn't be only theories and concepts, but that we should try doing something, and we need to start now. And this is what we're trying to do in Afrogeek. As an electronic and a computer engineer, I think as many others, that for Africa to develop, we need to use electronic and computing for our industrialization. In Afrogeek, we're gonna be building devices as thermometers, or things like robots or quadcopters, and those projects should solve African problems. So we'll be building devices that you can use at home and so on. In Afrogeek, we are using an open source platform called Arduino. In Arduino platform, you can copy schematics and codes and copy it to other people without violating any law, and you can even sell them. We know that through electronics, we can really push things forward and make Africa a better place. For our tutorials, you need not much requirements than your computer and a bit of goodwill. So just follow us on Afrogeek, and you'll be able to build your own devices that will help you solve some of your problems or even make some invention. So without wasting any time, we're gonna be having our first tutorial, which gonna be on a digital thermometer. See you. So welcome back on Afrogeek. Today we're gonna be having our first tutorial, which gonna talk about a digital thermometer. What is a thermometer? It's just a device that can detect the change in the temperature in the environment and then display it or make people know. So to do that, you need our Arduino board. Remember our Arduino platform that we're going to be using on almost all our tutorials here on Afrogeek. Arduino is a board that we use, that were made to ease electronic and embedded system designs. It has a microcontroller which contains a ROM, a RAM, and can manage those electronic pins, those pins that you can see right here. Arduino can be programmed using USB through this port that you see here, and then we connect it on a computer. It also has a power jack where we can actually connect a battery in case we want to deploy our system. And then we'll be having a board called breadboard. A breadboard is just like a normal electronic board or a copper board where you can actually plug connections or connect wire connectors. So we'll be using it to connect our electronic components such as resistance, capacitance, and so on. All the electronic components you can imagine. Other than that, you will have to display data. Once our sensor detects a change in the temperature, we have to make some calculations and then display them on this LCD screen to know exactly what is the temperature in the environment at that time. So we'll be using this 16x2 LCD screen. And then after that, we have our most important element actually, which is our sensor LM35. LM35 can detect the change of the temperature and then send that change of temperature through our pin number 2. You will also need a potentiometer, which gonna be used to adjust our contrast, the contrast on the LCD screen. We also need some wire connectors to connect on our breadboard and Arduino. So next I'm going to show you the schematics. For our project, you have to go to Arduino website and find the download section and download our Arduino IDE here. So if you're using a Linux operating system or a PC operating system or a Mac operating system, the Arduino IDE is available in this page, arduino.cc, and so you can download it. Arduino platform is an open source, so it means that you can actually copy projects and schematics that are available on their page, right, without violating any law, right? So, and you can copy it to other people, or you can make your own devices with them. You can actually even sell them if you want to without violating any law. So you go to create.arduino.cc and you will have a lot of projects. This is the C kit that we're going to be building. Those are the components that were presented on the website, and this is the schematics. This is the some kind of schematics. It's not exactly a schematic, but here we want to make it simple, so we put it this way. So we'll be having our LCD screen, our LM35 sensor, a potentiometer connected here. We'll be having a battery as well. For programming, we'll be using our Arduino IDE that we just downloaded, and then this is just how it works, but we're not gonna be using it now. Just to show you, this is our Arduino IDE. This is how it look like. Everything is available on create.arduino.cc, exactly on this page, Arduino Thermometer. So we will be having our Arduino board here, which gonna be connected. We're having our Arduino boards, and then there will be an LCD screen connected on it, and there will be also a sensor, our LM35 sensor, connected on it. And the middle pin that you see here, actually this is the V in of our sensor. It's the V out actually of our is the V out of our sensor. Our screen is connected on the digital in of our Arduino board, or the digital pins of our Arduino. Our potentiometer is connected on the screen, and others are on the board. It's all, and also on the power to adjust the contrast. Our battery will be connected on the power supplier jack, and so we'll be connecting a 5V on our breadboard, which gonna be the power supply. Our breadboard is gonna be supplied by Arduino using the 5V. You understand better when we'll be mounting our circuit. Alright, so welcome back on our tutorial, which is on the digital thermometer. So, and to do it, we're gonna start on our Arduino board and our breadboard. We want to connect our sensor LM35 on the breadboard. So we're gonna be connecting it here right now, so you can follow on the schematics that we have what we are doing exactly. It's connected, it's done, and now our LM35 should be powered. But before that, we need to connect power, or we need to provide the power on our breadboard. And to do that, we take it from our Arduino board. Arduino boards have a 5-volt pin, and then so we can actually, we're gonna block our green wire here, and then we will place it on the red line on our breadboard, which is here. And then now for the ground we have to use the black color because usually that's what it's used on other devices. So we're gonna connect it on ground right here, and now our breadboard is powered. And then after this, let's connect our sensor. To do that, the sensor actually has 3 pins. There is a ground and a 5-volt, and then there is a V out. So let's use again a color that we can recognize easily as minus, which is the white, and then we connect it on the power supplies. We connect it on the power supply. Remember that all the lines are connected together now, and then we connect the plus. Alright, and now we connect our digital, display, our LCD display. I'll explain to you guys later on how a LCD display works, but for now we just need to connect it. And so let's start by connecting the power supply, and that's it's pin number 2. So this is how the board works. On vertically, all those pins or holes are connected together. On the horizontal, all those holes are also connected together, especially on the division what I'm showing right now. And we'll go more into detail on our next tutorial or in the. And now we're going to be connecting our LCD, and then let's connect the plus and the minus of our LCD screen. Now we're going to connect our data pins, or make our data connections, which are those four wires. Yes, and they're going to be going on the digital pins of Arduino. We will have at first the second entry on Arduino. So those are, and they'll be connected 2, 3, 4, 5. So here exactly, as you can see. And now we're going to connect RW, which is read and write. RW is read and write, because when we want to send data, right, our board should ask the LCD that right now I'm going to send data and please get those data, and we're going to connect it exactly here on the pin number 11, on pin number 11 of the digital of Arduino. Now let's connect the ground of our another ground again, and then after this let's connect another wire, important wire, which is RS. RS is to tell the boards whether we want to read data or we want to send data. So anyway, I will go more into detail on the next tutorials. So, and it's connected on pin number 12. After this we have we have 3 other connections which gonna be done on our boards, and for that let's connect, they're gonna be connected on our potentiometer. And for that, let's connect the potentiometer first. We connect it anywhere, let's say here for example. Let's see, and now once it's connected, Okay, we're gonna to use these 3 wires. The first, it's exactly here. It'll be going here. So I'll be going to the first, let's say the first wire or the first connection of the potentiometer, and the other will be going on the power supply on the 5 volt, and the last one will be going to the ground. And now you need 2 more wires, right? 2 more wires to connect. 2 more wires to connect our potentiometer on the 2 other pins of our potentiometer. So just now we were connecting the plus and the minus of our LCD, and so let's connect it. Now, okay, we have to shift all those wires, because there is a central division on the breadboard actually. So all the wires that were connected the other side will not be connected, because those 2 parts are not connected, right? So that's why we are bringing all the wires on this side to make sure that, because that's where our power supply is, to make sure that we will not have any problem. And now our last connection, which is actually the most important, is the middle or the second connection of our LM35 sensor. So how it works, that voltage just changes whenever there is a change in temperature. So we're going to be connecting it on our analog input in A0, connection A0 on our Arduino. What is an analog in? It's an analog to digital converter. It means it converts an analog component and it converts an analog signal to a digital signal, and then we take those signals from Arduino and make calculation. And then that's it. I will see you next time for programming. After mounting our circuit with our Arduino LM35 and our digital display LCD 16x2, now we're going to program our device, or let's say precisely our Arduino board. So let's connect our board through the USB cable, and see. So the code is available in create.arduino.cc. So these are the codes that we're going to copy. We just select it first and we copy it, and let's go on our Arduino IDE and paste it here, Arduino IDE. So we paste, all right, and then now what we will try to do is to upload, we're going to upload our codes on our Arduino board. So we copy this code, and we are not violating anything, so you don't have to worry. Just copy it and paste, and then you can modify it, and you can copy to a friend and so on, without any fear. Nothing gonna happen to you. Alright, so let's see what we can understand on this code. Here we are declaring a liquid crystal display, and then we are indicating that remember just now when we were mounting the circuit, we connect our RW on 11, our RS on 12, and we had 4 digital connections which were on pin 2, 3, 4 and 5 of our Arduino board. This is exactly what is written here. So we are declaring here that we have a sensor, and actually we are just declaring that we're gonna be connecting it on the analog pin 0. Alright, I won't go too much into details. For now, all you need is to copy these codes, paste it here on your Arduino IDE and upload it. Alright, let's see what we're gonna do. We will try to print the temperature in my hometown, which is Yaoundé, and so we're gonna make it very easily. Let's now upload our code into Arduino board. Let's see how I'll show you how it's done right now. All right, we just click here on upload. We click here and it's gonna compile first, and now it's uploading and done uploading. And you can see, I don't know whether it appears, you can see the temperature in Yaoundé in degrees Celsius and Fahrenheit. Okay, but we don't need Fahrenheit, for example, so let's just modify our codes a little bit and write only the degree Celsius. So to do that, we have to come here. Alright, first let's arrange the codes a little bit. Don't worry about all this because I'm not changing much things. And then even if you don't understand anything on the code, it's okay for now. So I'm using double slash here just to cancel those lines. That it's in programming, it's called a comment. So I'm commenting to cancel those lines, so we wouldn't have any Faraday anymore. Now we have only the degree Celsius. We have the temperature in Yaoundé right now, which is 34 degrees Celsius. All right, and it's cool. So let's see. Yeah. Now that we are done with programming, we will try to test our device to see whether it's working properly. So what we're going to do is using a fresh drink bottle, and then place it on our LM35 sensor and see whether the temperature gonna go down as it's a bit cold. Right, so we were on 33 degrees Celsius. Now we are on 32 degrees Celsius, right? And then we are going to 31 degrees Celsius, and then let's wait for a while, a few more seconds, and see what's happening. And then okay, we are having 30 degrees Celsius, and then let's see again and see whether we are having another change. Probably change again. Yes, and it's changing to 29 degrees Celsius. Right, it's all right. It's stable at 29 degrees Celsius. All right, let's remove it. Normally, the temperature, the surrounding temperature gonna be displayed back. So it's going up 31, 30. You are 30, 31, 32, and now it's 32. So we have a 32 degrees Celsius right now. So this digital thermometer can be used for a lot of things at home, in industry, in hospitals, outdoor, and so on. And it was made by you using Arduino. Right? That's great. So we just finished our first tutorial on the digital thermometer, but that thermometer was made on a breadboard, right? So it's just a prototype right now. So next time we're gonna try to make it a real device. We need to put it in a box, in a little box, right? We can see now that it's connected on the computer, and that's what gives that supplies the power. We have to adapt a battery on it, and it has to be smaller. So this circuit is gonna be built on a red copper circuit, a perf board as we call it. So follow us on Afrogeek on Twitter, Facebook, YouTube, Instagram, and Pinterest. Please comment, like, follow us. We are waiting for your comments. See you next time.